All right, this is going to be a pretty quick video. I just want to kind of introduce this idea of congruence to you. Now, the good thing is you have a little longer to get that compass if you need it. So make sure you bring that compass to class next time because we're going to be using it. So if you don't have it, you won't be able to do what you need. All right, but I want to kind of introduce this idea of triangle congruence so that we can kind of hit the ground running when we start next week. All right, let me kind of share this screen with you real quick. All right, here we go. All right, we're going to start talking about congruent triangles. Now, we're going to eventually talk about congruent triangles and similar triangles. So I'm just going to kind of introduce kind of the descriptions of both, and then I'll give you the formal definitions kind of as we go through this section. All right, congruent figures have the same size and shape. All right, so in other words, they match exactly. So if you had two triangles that were congruent, if you laid one on top of the other, everything would fit perfectly, okay? Similar figures have the same shape, but they don't necessarily have the same size. So we're going to talk about congruent figures today and for the next several days. And then after a couple of weeks, then we'll talk about similar, but I do want to make sure you understand the difference. So congruent figures have the same size and shape. Similar figures only have to have the same shape, okay? So one time in Math 211, I asked somebody to give me a real life example of the difference between like congruent things and similar things. And one of my students gave the best example. He did such a great job. He said, well, if I was going to show my students congruent and similar, he said, I would go to Walmart and I would buy packs of t-shirts. He said, I would buy a pack of extra large t-shirts and a pack of small t-shirts. And he said, I would pull out two of the extra large t-shirts and tell them these two t-shirts are congruent. Because if I put one on top of the other, they match exactly. They're exactly the same shape and they're exactly the same size. They're both extra large t-shirts, just alike. And he said, but if I took one of the extra larges and I took one out of the small pack and put them up, that would be an example of similar because the two t-shirts have the same shape, but they don't necessarily have to have the same size. I thought that was brilliant. Isn't that smart? See, y'all are way smarter than me. Okay, so we're going to talk about congruent figures. Now, it could be any kind of figure. It could be four-leaf clovers. It could be Easter bunnies. It could be trapezoids, but we're going to mainly talk about congruent triangles. So that's what we're going to kind of talk about in this video, just kind of an intro. All right, now this is going to be the formal definition of congruent triangles. So on your next test, if I say define triangle ABC is congruent to triangle DEF, and then go back and notice on this other slide, I showed you the symbol for congruence, and then I showed you the symbol for similar. So the symbol for congruence looks like an equals with this little wavy symbol over the top. It's called a tilde, okay? So that's the symbol for congruent. We've already talked about that kind of during the semester. But if on a test I say define triangle ABC is congruent to triangle DEF, I don't want you to tell me they have the same size and shape. That's a description and it's a fact, but it's not a formal definition. The formal definition of congruent triangles is 6 statements. 3 statements about congruent sides and 3 statements about congruent angles. Because congruent triangles have each pair of corresponding sides are the same length and each pair of corresponding angles are the same measure. So if you write them this way, the order is important because from this way, I would know that segment AB had to be congruent to segment DE on the other triangle. Now, how did I know that those two went together? Because the first 2 here go with the first 2 there. Then I would know that side BC on this triangle has exactly the same measure as side EF on this triangle. So if this one's 6 inches, that one's going to be 6 inches. Okay, and then AC, the first and the third here, has to match DF, the first and the third here. So that's how you would know what order the segments go in. So if DF is 2 inches, AC is 2 inches. If AB is 5 meters, DE is 5 meters. So does that make sense about the segment length on this triangle is exactly the same as the segment length on that triangle? All right, then the angles match. The first angle here's got to be congruent to the first angle there. So if A is 30 degrees, D is 30 degrees. Angle B, the middle one here, has to match the middle one there. So B is congruent to E and C is congruent to F. Now, you need to memorize that already because I'm going to ask that on a pop test very soon. Hint, hint, hint. Okay, so over here, let's double check. All right, let me show you something. If I guarantee you that triangle ABC is exactly the same as triangle DEF, that means I should be able to rotate this somehow and put it on top and have this triangle and this triangle match exactly. So if I know for sure this is true, which angle does A have to go with? Has to go with D, doesn't it? So if A is 40 degrees, that means I know for sure that D is 40 degrees. Okay. Well, what about B and E? B and E match. So if E is 65 degrees, that guarantees me that B is going to have to be 65 degrees. Now, how would I find C? Well, we already know how to do that. We've already talked about that. Remember, all the angles in a triangle have to add up to 180. So if you do 40 and you add that 65 to it, that's going to give you 105. So that's got to be 105. And sure enough, 40 and 65 is 105. Let me fix this. All right, let me erase this. See, I wasn't paying any attention. That angle is not. Okay. 105 is how would I figure out the angle that's missing? Remember, I've got to subtract from 180. So that's what happens when you're not paying attention. So 180 minus 105 is going to give me 75. So I've got 75 here, and I've got, again, 75 over here. So sure enough, A and D match. They're both 40. C and F match. They're both 75. And B and E match. They're both 65. Okay, so that's how we might be able to find missing things. Now, if I knew that AB was 4 inches, which side over here would be 4 inches? Don't think it's just the left goes with the left. Look at what it says. AB's got to match DE. So DE would be 4 inches. So make sure that you're looking at this, not necessarily the pictures. Okay, so just because this is on the left doesn't mean it's going to go with the side on the left over here. All right. So make sure you understand that. Now, the other thing is look at this one. I say, are these triangles congruent? Well, now here's one thing you can do. How can I find this missing side down here? Well, isn't it a right triangle? So doesn't that Pythagorean theorem work? So A squared plus B squared would have to equal C squared. So remember, the side across from the right angle is your hypotenuse. So that's how I know that C is 5. And one of my legs is 3. It doesn't matter whether I let that be A or B. And then I have to find the other one. So 3 times 3 is 9. And of course, 5 times 5, that 5 squared is going to give me 25. So if I subtract 9 from both sides, my B squared is going to be 16, which says B is either a positive or a negative 4. But this is the length, so that's got to be a positive 4. Now, how would I find this missing side? Wouldn't I do exactly the same thing? Only instead of knowing the 3, I would know a 4. And it ends up being that ends up being a 3. Okay, so that's how I could find the missing sides. Now, how could I find the missing angles? Well, I know that's a right angle. I know this is 64. So again, how would I find that missing angle? Just like I did up here, I'd have to add these two. So 90 plus 64 is going to give me 154. And remember, they have to add up to 180. So if I have 180 and I subtract the 164, isn't that going to give me 16 degrees? So that right there is 16 degrees. Okay. Well, how would I find this missing angle? Well, again, I'd have to add the 90 and the 26. All right. Let me do this. Okay. Oop, that's not 16. Let's see what we've got. All right, let's see what we've got. So I've got 90 plus my 26 is 116. All right. So if I subtract 180 minus 116, wouldn't I end up getting what? 66? Excuse me, 64. Let me get my calculator and make sure I'm doing it right. I'm doing it in my head. All right. So if I do the 90 plus the 26, I do get 116, and 180 minus 116 is indeed 64. So this would be 64. All right, let's go check over here. If I do 90 plus 64, I get 154. Oh, so that needs to be 154. So that needs to be 26. So that needs to be a 26. All right, now I would double check anytime and add them back up, because I knew I made a mistake here, because when I added them back on my calculator, I didn't get 180 degrees. So do you see that all three sides here match all three sides here, and all three angles here match all three angles here? Well, how would I write it? Well, I know I've got triangle ABC would be congruent to, let's see which triangle. Well, how would I write it? Well, A is 26. Which angle over here is 26? M. So if A is first, M has to come first. Over here, B is 90 and O is 90. So if B is in the middle, O's got to be in the middle. And then double check. C is 64 and N is 64. So if C comes last, N has to come last. So the order that you write them matters. Okay, AB is supposed to match MO. AB is 3 and MO is 3. See, that works. BC is supposed to be congruent to ON. So BC is 4 and ON is 4. So sure enough, I know what order to write them, because I've got to write the angles that are congruent to each other in the same position. So whatever angle comes first here has got to be the same measure as whatever angle comes first there. The middle angle here has got to be the same measure as the middle angle there, and so forth. So once you write down the order, always double check these 6 statements. Okay? So make sure we're clear on that. All right, so let's go look at one more thing real quick. All right, look at this one. All right. Again, if I guarantee you on this one that triangle MAT is congruent to triangle BDE, and it says solve for the variables, don't do it by looking at it. The first thing you do is write down your 6 statements. If you know that this triangle is congruent to this one, what do you know? Well, you know that side MA has got to be congruent to which one? The first 2 here with the first 2 here, BD. Okay, and then you would know the last 2 here go with the last 2 here. So you would know that AT would have to be congruent to DE. And then in the last side, MT, so segment MT, would have to be congruent to the first and the last here, BE. All right, now what about your angles? Well, you would know that angle A has got to be congruent to which angle? Well, if A is in the middle, D is in the middle. All right, so it's got to go with angle D. What about angle M? Which one is it congruent to? Well, if I know that this triangle is congruent to this one, then M's got to go with D. With B, because the first one here has to match the first one there. And then angle T would have to be congruent to the last one over here, which is angle E. So on a test, if I said define triangle MAT congruent to triangle BDE, I'd expect these 6 statements. Now look at why this makes it easier. All right, what's angle M supposed to match? Angle B. So if angle M is 50, that means angle B has to be 50. All right. Look why this helps me. All right, I also know that, what about T? Well, angle T's got to match angle E. So T and E have to be the same. So if E is 30, that means T is going to have to be 30. Now, why does that help me find X? Because again, don't all three of these have to add up to 180. So 50 plus 30 is 80, and 180 minus my 80 is going to leave me 100. So that means that's going to have to be 100. All right. Oh, let me fix it. What did I do a minute ago? I'll fix that in a second. Where's my eraser? I wasn't paying attention again. Okay. All right. So let's fix it. Okay. All right, here we go. So X is 100. So let me go back and double check what my other one had to be. Which one over here was 50? B was Y. Y was 50. So make sure you put them in the right blank. Let's double check and make sure I'm correct. M is supposed to match B. So if M is 50, B would have to be 50. So that's Y. All right. A and D match, and T and E match. So if E is 30, T has to be 30. So again, do you understand? I would know that one is 100 also, but they didn't ask me to find that one. Now look what else I know. I know that MT's got to match BE. So BE would have to be 15. All right, look what else I know. I know that ED, let's see, DE's got to match AT. So AT has to match, what did we say? AT. All right. AT's got to have the same length as DE. So if DE is 11, AT has to be 11. So Z has to be 11. Now look what else you would know that they didn't ask. DB is 8. What does DB have to match? DB has to match MA. So if this one's 8, that one would be 8, but they didn't ask me that. So the order of these things makes a difference. So one of the things I expect you to be able to do is, if I give you congruent triangles, I expect you to be able to figure out which angles are the same measure and which sides are the same measure and fill those in. The other thing I expect you to be able to do is, if I give you two triangles and say, are they congruent? You're looking for if all three sides are congruent to all three sides and all three angles are congruent to all three angles. Now, next week, we're going to do a shortcut. And sometimes instead of knowing all 6 of those, you only have to know 3 of them. All right. So get all that written in your notes, and then I will see you next week.